Hi everybody, welcome back to this new WeeW tutorial, and today you will learn how to set up a serial EEPROM memory. So by the end of this program, you will be able to save data in the EEPROM and load it from this EEPROM too. And this is what we are going to build together. So here we already have saved the hello WeeW array into the EEPROM, and you will see that we will visualize it by UART, and this one we are going to load the data from the EEPROM. So if I save here, build, okay, and you can see here in the UART communication after loading the code that I have hello WeeW inside the EEPROM. So stay tuned to see how to save and load from the EEPROM. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment, or subscribe and stay tuned. As usual, the code that we are going to write together is available on GitHub. You can find the link in the description below. We are going to use only C language, and the program to code will be KL version 5. Finally, the level is WeeW, but if you need to get more understanding about the I2C communication library, you can back to the tutorial. And if you are looking to just understand the EEPROM memory working, this tutorial will be just fine. Okay, for the hardware, we are going to use the STM32F1 aka Blue Pill, the FTDI FT232 to allow the UART communication between the STM32F1 and the computer. Finally, we are going to use the AT24C serial EEPROM, and this will be the MH board. So this tutorial can be also considered as a EEPROM tutorial, and this is the part 1. We're going to set up the store and load data using the ATC24 and visualize this communication using the UART technology. So this tutorial, at the beginning, we will have a quick review on the AT24C and understand how it works. Then we will take a look on the AT24C memory split, and this is extremely important part. After that, we are starting to code and set up the save functions, the load functions, and we finish everything by having a UART communication example for the save and load. Okay, so let's have a quick review on the ATC24. So as you can see here, this is the small chip. It's a very simple one, having 8 pins. So it's an EEPROM memory, and it have 8 pins, so this is already said. So it has 8 possible I2C addresses, and this is based on from A0 to A2. And also this created if A0 to A2 are high, it will be 1. If they are connected to the ground, it will be 0. So quite simple, but very useful if you would like to have many EEPROM series of this type of the AT24. Okay, so this internal memory can be 4K or 8K, depends on the model. So the ATC, the AT24C32 is a 4K, where the AT24C64 is the 8K. Quite very simple and easy, and they are organized at 8-bit or 1 byte. So you do have 4096 bytes of memory. So the endurance, you can have 1 million write cycle. I'm not sure if this number is big or not, but careful not to put the microcontroller making an update every 10 milliseconds, so your chip will die after a few days. After that, so there is a write protect pin, so you can protect your pin against write if you change, so you can make a kind of switch and connect it, so there's no write operation happening. This is a chip that can work on 100 kilohertz or 400 kilohertz for the I2C communication, quite fast and good. And finally, the operation is between 2.5 to 5.5, so this works on the STM32F1 and also the Arduino, which is really great. Okay, so we are going to use this chip in the board, the MH board. A quick look on the MH board. This board has 2 chips, so it's actually a chip, so it's around $1. It has the DS3231, which is a real clock timer, and we have seen that in the previous tutorial. It has also the address of the hexadecimal D0, and also it has the ATC, or the serial name, which is the ATHYC523. It's quite long, but you can see it's a small one in the bottom of the board. And finally, the address of the ATC for this connection is the hexadecimal AE. Why this we'll see later. And there's a backup battery in the back of the board, so it can be used even when it is offline. Finally, it's both of them are between 2.3 and 5.5 operation. And why we said it has this memory, the AE, simply because if you see the connection here of the AT24, you can see that both A0, A1 and A2 are connected to VCC. So if you, when you connect and you power on, this 3-1 will be high, so you need to put 1 there. Okay, and also the other point that is extremely important, both chips are connected to the same pin, so you don't need to solder the other one that you do have in your right. Okay, so let's take a look now to the memory split of the AT24C. So the memory split actually is splitted on pages organized of 32 bytes. So one page is 32 bytes. So that's how the memory is splitted inside the AT24. After that, so if you confirm, during a page read operation, this is extremely important. So the microcontroller can transmit up to 31 data or words. So you can't do more than that. So the data word address is tracked using only, so you do have 4,000 addresses or 4092 addresses. You can control like the the memory will be looking only to the first lower 5 bits. So if this one exceed that, that problem will happen, and here where comes the red area, which is if you write more than 32 bytes within the page, and then the data will roll over and come back to 0 of the same page. So be very careful about this point. We will work on it in the part 2 of this tutorial for EEPROM, but be very careful about this one. So you need always to monitor and check which byte are you in the address that you are using. Okay, so we had a quick review on the ATC and how the memory. So now that's a good point to start making the code and create the save functions. Okay, so this is our initial code page or the main page. So first of all, we are going to need at this level only 3 libraries, which is the SysTick time library that generates the delays, and this is one of the most important one. The AT24C drive library and the UART library that we will see only at the end of this tutorial. I also added this AT24C library, which is empty for the moment. So in the header file, I'm adding the I2C drive library because we will need to have the I2C communication API that we created to use, and the help function later on. This is really advanced. Finally, the SysTick time, because we will need a bit of time later on. Okay, so first of all, let's start by setting up the address of this drive. So and this is more to be dry, or do not repeat ourselves. So let's generate this one. This is the most simple function that we create, but that will help later on, and certainly for this one when you can change quite a lot. So for this one, the ATC24AD, so which will add here the ATs. So we are going to use the I2C address and I2C, so depends on the I2C we are going to use, and the address for this one is the hexadecimal AE, and this is the address that we need. And after that, we just have to add the read write. Very simple, very easy, nothing really hard to manage. Brilliant. So after that, what we can do now, so we are going to set up a transmission or saving byte, only 1 byte function. So before going directly to here, let's take a look to the tutorial, the datasheet, which is a very simple 20 pages or 19 pages datasheet. Very simple, very clear. I think Atmel was really good on making this datasheet. And if you go to the write operation directly, so there is a bit of byte operation and page write, and this is what we are going to make functions, and the first one, the byte operation, the byte address, if you like to start right. So first you send the address of the device, but after that the register address, or the address we would like you to write the data, is a 2-byte address. And this is extremely important because in the previous examples we were using only 1 byte address. So now we have to build a 2-byte address first, so sending 2-byte address, and then the data where we would like to write in a page. So it will be, as usual, we are going to write the address with the byte 1 and 2, and we can keep writing the data. So we have to be worried here about the page, but not within this part of this tutorial. Okay, so 2-byte of address and then the data for the simple one. So let's make this one bigger here. So let's open this address. So this one, first of all, we need to confirm which I2C. Here, if you see, we changed, it's not anymore a char but a short, because we need 2 bytes, and after that char, which is only data. Okay, so let's start doing it. So first of all, we have to create a char address, which is the first register, or reg1 we call it, which will be equal to, so this reg here. Okay, and that will be moved by 8 bytes here. Okay, and after that we need to put AND 0x00FF, and this is how we get the first byte. Okay, and after that what we can do is copying same thing here, and we are putting 2 on this one. And what we can do after that, so it's not doing only this one, but we're putting only the register here, and like this. So I don't need this parentheses anymore, and the code should be fine. Let me add comma at the end. Okay, so now we do have the addresses ready, so we can start using our I2C library. So I2C start to start the communication, and this is I2C, so which I2C we are going to use. And after that we are going to use the ATC address, and as usual it will be using the same I2C, and it will be using 0 here as we are going to save. Okay, after that we just use the I2C data function. So if we put data here, and we start by sending register 1 here. Okay, and we just copy paste because this is quite a simple thing to do. So yeah, I need to add I2C here and I2C here too. Okay, so and here the register 2. So we just copy again, and after that we are just sending not the register but the data that we would like to do. Finally, to stop everything, we do I2C stop, I2C stop here, and we need to put just the I2C. It's very simple, very straightforward, but there is one thing that you must add or take in account when after writing. This is extremely important because you need to wait just a second. There is a 20 millisecond wait. So if I go to write, so the byte write, so here you have to so there is internal operation, and you have to write for this TWR or T write. So if I go and look for the TWR and go for the previous one here, the TWR should be between 20 to 10 milliseconds. We are going to put in 20 milliseconds to not have any issues. So 20 millisecond waiting, just in case, to avoid any issues with the operation. So you can see it's a very simple, very straightforward operation. Most important to not forget to do this, to split the registers and send this one. Okay, so now we can start saving as a page level or sending a whole array. So let's go. It's almost exactly same stuff, all that but we are going to add the array and the length of the array, so we can send the right length to the data. Okay, so let's start. So we can immediately just copy paste, same as this one. We are going to change it a little bit later on. So we take this register, we send this one, but after that we have to start doing some stuff here, very important one. So we send it this one, so now we can add kind of a int I here. Okay, and what we can do, we start our loop for I equals 0, I less than data len, okay, and I plus plus. Okay, oh sorry. Okay, so here we just we take this I2C data, we copy it, we do like this, and instead of data we just put str of I. A very straightforward job. And why I'm creating these two functions, because sometimes we just need to send one variable and we don't need to create a whole array for it, so that can be very useful from time to time. Okay, I think here we are quite good, so there is no issue at all, and we could finalize the part where we save the data from into the EEPROM memory. So now that we finished the save functions, let's jump and work on the load functions for our AT24. So exactly same as we have done for the save function, we are going to create two functions for load, one that will load only 1 byte and one that will start loading a whole page. So let's start with the first one, which is quite simple here. So let's put here, and let's put let's call it char result, just a very simple one, and we can put like this. Okay, and we can get inspired from the save byte where exactly same stuff is happening, so up to here. So let's do this, and after that we need to start again. So this is how to read from a specific location, and where we're putting here 1, and this is the one that where we are starting to get read from the byte. So after that result, we will put result will be equal to and I2C. So we put I2C, and so Rx I2C Rx, so the receive one, and of course we are selecting the I2C that we are going to put, and as we are reading only one, it will be we are going to send and not acknowledge a signal. So if you do have some question about this one, there's a whole tutorial about the I2C libraries, so feel free to take a look at it. And then we just finish the communication, so I2C stop, yeah, and we just put whatever the I2C that will be used. And we don't forget to return at the end the result char. Okay, I think that's the whole function here. So now we can jump to the one that will be bringing back the whole page, let's say. So let's go here, and we can really copy a lot of this one, so we don't need the result. We can copy up to here. Let's put this one here, and we are going to use int I because we are going to loop through this one. So what we need to do is, for opening the loop, I equal to 0, I less than data len. So the I++, actually there's a small thing, so it's not I equal to data len less than data len, but data len -1. Okay, so what we are going to do here is we are going to read each time here. So str of I will be equal to exactly this one here. Okay, but we are going to put an acknowledge, and the last one will be with a not acknowledged. So we are going to copy this one here, and we're putting a not acknowledged one to close and stop the communication. Okay, so that was the last step. So now we do have our functions ready, so we can really read and so save and load using bytes and pages. So we are ready now to make the first demonstration and visualize how the communication is working. So now we created the save and load function. Nothing better to have an example using UART communication to see what's happening inside the system. Okay, so before we move to the main C program, just one thing I have done, and just to save time, I copied all the functions that we have created in the AT24C header file, so we can use them in the main program. And then let's take a quick look on the circuit that we do have. So this is a circuit that we do have here, and this is our STM32F1 connected to the MH board like this, and the FTDI is connected to the UART2, the pin A2 and A3, where the I2C communication is which is I2C2 and is driven by B11 and B10 pin. Okay, so I can zoom here and you can see how I have used the wiring here to make the communication with this small MH board. Okay, so let's quickly go to the main program and start working on it. It should be straightforward and simple. First of all, we have to put the sysdig init. This is to create delay functions, so sysdig init. And then after that, let's make the UART init. So UART init, so it will be, okay, let's check UART init, yes, this one, and we are going to use UART2, and the baud rate will be 115,200. After that, we need to make the I2C init like this, and it will be I2C2, and we would like to have the I2C fast mode. Okay, then after doing so, we are able normally technically to save. So let's copy this function here and let's go to save page and try to start using it like this. So let's go here, and so the I2C we would like to use is number 2. The register, the register location, let's start saving from 0, and the string, let's make an array, so a char of array that we call it save, and we'll have around 11 char, and this will equal to our infamous hello WeeW. Okay, and let's have a line return here. Okay, so and we put end over gamma. That should be fine. Hello WeeW, but something too long. Okay, so let's put 12. That should be make it. Yep, that's perfect. So for the string it will be save, and for the char here we need to have a 12 one. Okay, that looks good. So after that, we would like to get the data from the EEPROM memory. So let's use the load one and put it here. So we are going to use the I2C2. We are going to start reading from the 0 register, and the string, let's have a load here. We call it load, so just copy this one, making this one here, we call it load, and it will have exactly same stuff here, load, like this. and the char we would like to have 11, actually 12, and we are good. So finally what we would like to have is sending by UART the array that we are going to load or to get from the EEPROM. So here UART, and we are going to use UART2, and the load will be what we are going to send is just load. Brilliant. So if the program will work well, we should see, let me bring the program that we are going to use. We should see here, this is the H term, and the connection is already established with the baud rate. So we should see hello WeeW appearing here. As we have saved it in the EEPROM and we'll load it after that, then we will be able to make it. So let's save, build, and see. Oh no, crap. So something did happen. Usually in this situation, the first thing to do is to take a look to the save function and then load function. So let's go to the save function here and to check if, not byte, but we are going to use the page function. So we do have our start, the address, we send the data. Of course, forgot to add the stop function here. Okay, let's put this one, save, let's try to save, build, and let's run again. We do have our hello WeeW here, and that's brilliant. So let's do it again. Yeah, we do have hello WeeW. So I'm removing the hexadecimal picture, and you can see we do have hello WeeW. So let's go further and even remove this part. So we don't have this one anymore. So if I save, build, so we are not anymore loading nothing, and if I run again, you see I'm having the hello WeeW. So even when let's make it small here, and even each time if I run to the reset, I should see hello WeeW, which is written from or coming from the ATC24, or sorry, it's not ATC24 but AT24C. I need to change this one later on, but you can see that we can have the data saved exactly as we want it. Okay, that was good. So we created a small memory, but actually the target of this memory is to be a logger, and this is what we are going to see in the part 2 of this tutorial.